Hello team, today's challenge is FizzBuzz Explosion, where we're given the string FizzBuzz and we need to iterate through it and create a brand new string until we have enough Z characters to tally whatever we need. And then what we do is we return the number of steps it took to get there. So each time we're going to loop through, so FizzBuzz here, we're going to do the FizzBuzz math, which generates a brand new string. And then if that has enough Zs, great, we return how many steps we took. Otherwise, we feed this new string into our loop and start again, which is going to make it really long strings. We'll talk about that in a second. But getting right into this, we're going to jump into the code, and I'm going to bring in pretty much the function that I've used in all of these challenges. So there are plenty of them. I will point to at least one where you can see how this is generated, but really fast, this is going to be Fizz, if I can spell it, FizzBuzz L, okay? And for this, we usually send in a number and do stuff. What do? Well, we check the string, right? String equals an empty string. And down here, if, not if, sorry, but we return string. If that is truly equal to an empty string, then we return the number. Otherwise, we return the string. And what do we do inside? Well, we do some modulo math, right? So if n modulo 3 equals 0, then we go string plus equals fizz. Now, a little quick tip here before I do the next line. This time around, they're using lowercase. In previous challenges, they used uppercase. Okay, so be careful with that because that tripped me up before I change some of the code that will come in the future. Okay, but usually they have uppercase F or uppercase B in the case of Buzz, which is right here. And that's something to be aware of. So if you're just copy and pasting code from other places, that might catch you. It definitely caught me. So be aware. Okay. But module 5, and this changes to Buzz. And here is our original FizzBuzz element. Okay. The change that I want to make to this is I want to be able to supply a letter, okay, or some sort of other element, right? Whatever that might be. And if instead of returning the number, I want to be able to return that element, okay? But what happens if I don't supply element? What if I just want to use it the way that I always have, where I only supply the number and I want to feed that number down here? Well, I absolutely can. I just need an extra line, right? It's if there is no element, if it is undefined, then L equals N, okay? And that makes sure that we take that number, we slot it into the element, which returns down here, and this does the thing. Could we do something like set this to null? Absolutely, right? Why not? It will still work. And in fact, if you were doing TypeScript or something like that, you probably would have to do that, right? If you don't send a default argument, it assumes that it's required. So you might have to do something like that. But for today, this is all we really need, okay? Down in our main function, we are going to set some stuff up. So the first is going to be our regular expression, okay? Because what are we searching for? Well, it's going to be, I'm going to set it to global and case insensitive here, but it is going to be all of the fizz characters, all of the buzz characters, and all those Z's, right? Which will show up in both, actually. So fizz, buzz, we're going to grab them all, okay? The next thing that we're going to do is we're going to set up our count, and we're going to set it to 0, okay? This is what we're going to return, so we can do that. And then down in here, we start running a loop, okay? We're going to do it as while, which is excellent. Now, the other thing that we haven't done before jumping into that is I haven't supplied the FizzBuzz anywhere, right? Where is that? They don't give it to us, and maybe they really should. So right up here in our arguments, I'm going to set it to word equal to FizzBuzz, excellent. And this, so what this is going to do is it's going to allow us to send in any word, which means now that I'm thinking about it, if we can send in any word and we're only tackling the whatever character it is, then maybe this regular expression doesn't really work. Maybe we should just go A to Z, capturing any word, any letters, and then we're going to loop through them, okay? For today, we're only working on the word FizzBuzz, but in the future they might. So I'm going to change it to A to Z. It's still going to be global, case insensitive. Brilliant, okay? Now that while loop. So right here, I'm going to take that word and I'm going to match. What am I going to match on? Well, I'm going to match on the letter Z, right? Globally, case insensitive, just like that. And there is nothing else here, but I do want the length because the global attribute will return an array of found items, okay? So using match with global returns that array of all the places that it found the letter Z or Z, which means that we can peel off the length on that and make sure that it is less than target Z count, which should light that up. It absolutely does. And we drop in and do stuff. What do? Well, first we need to get the index, okay? Sorry, we increment the count. I'm getting ahead of myself here, but we increment the count by 1. So count plus plus or count plus equals 1. We do that. And then we reset our word, okay? And our word is going to be replace. Right here, we're going to do it on the regular expression. That's going to give us a match, which is individual letters, right? We haven't done the plus sign or anything like that. It is individual letters, so we're going to grab on those. It's going to give us the offset, which is kind of like the index, right? And that's how we usually use it, right? And then down here, we're going to do stuff. So this is the place that I was hinting at before where we get an index, okay? Now, our word is 1 indexed, okay? Instead of being 0 indexed. But the offset is going to be 0 indexed. So what we need here is we need this to be adjusted to offset plus 1, just so that we're in the right place. This also protects us from having that 0 index. 0 modulo 3 is what? Well, it's 0, right? So with a 0 match, the first element would be replaced to FizzBuzz. Not quite what we're looking for. So this protects against that as well, okay? And then finally, we return what? Well, we return FizzBuzz L. We grab this, bring it down, and toss in the 2 things. So the index is our number, and the match is our word. At this point, it should work. It absolutely does, okay? We can get rid of this loop if we want. So if we wanted to, we could grab all of this, copying it, bringing it down for a second, and changing a few things. What are we changing? Well, the first thing is this while loop. I'm going to grab the condition of this while loop and cut it out, okay? And then up here, I'm going to go if, pasting that in, then return count, okay? This isn't quite right though, because this drops into our loop, and what we want is we want to flip this sign to be greater than equal to. So if we have enough letter Zs inside to meet our target Z count, then just return whatever the count is. Count being down here, we really should put it somewhere else. We're going to bring it up and go count equals 0. That way we can get rid of this part. Excellent. And maybe just add a return there, right? Clean it up, making it nice. Then we take everything inside of the while loop, bring it up, indent it out, and get rid of this while loop completely. Now we do still have to change things, okay? The return isn't going to work. Returning the count and the count, that's not going to work. But the first thing here is that we should return, or we should fix our word, okay? Our word is going to be const. We're going to set it to new count. What the? Const new word, okay? So now we're capturing that word, which is really important because right here, we're going to pass that into this, explode FizzBuzz. Copying it, bringing it down like this. Target Z count stays the same, but our word is now new word, and our count is plus 1, okay? At this point, it should still work, and now we have recursion going on, right? So whereas before we used a loop, Now we're doing it recursively to get there. We work all the way down, then all the way back up. Great. Which one is faster? Neither. They're both equally slow. And when I say slow, I mean very slow. Here is my results for it. You can see 13 ops per second, right? So the while loop, 13 ops per second. I thought I could make it faster by getting rid of the regular expression and doing a split with a map. It only added one extra op per second. It didn't do anything, right? And then, of course, the recursion being like it is, still 13 ops per second, very painfully slow. Now, the question is why, right? Why? And that's why I'm showing you this today. I can comment these big numbers out, run this again, and if we wait just a split second here, there it is, you can see that our numbers jump substantially, right? So there is a thing in here where it is related to the size of whatever we're trying to do, the number of letter Zs that we're trying to get at. Right here, we're looking for 1 million Zs, which is a huge number. But even at the small numbers, right, it still grows. And the reason for that, if I can find my little bit of code here, copying this in, this will actually be easier to think about with the loop. So I'm going to bring that back for a second. But right above this, I'm going to paste in this comment. So the first one we know, okay? We pass in FizzBuzz, which is 8 characters. And then we loop on it because, hey, we don't have enough letters. We don't have enough Zs to get out of this loop. And what ends up happening is that we replace, based on the FizzBuzz pattern, we replace the 3s and the 5s and the 15s, right, with their representative fizz or buzz. And each time we do that, we are adding either 4 or 8 letters, 2 of which are Z, or if we do the fizz buzz, the 8 letters, 4 of which are Z, right? So we're growing it quite quickly, which is why we go from 8 letters to 17. And that example is right here. This is that 17, right? With the 9 Zs in there. So there it is. When we go again, we don't pass in the original FizzBuzz, we pass in the new thing that we created, right? It is exponentially bigger. It is more than twice the size of our original string. And from there, we iterate on every single letter in that string, which brings us to 42, right? We add in new fizzes, new buzzes, new fizz buzzes, and we get 42 characters. Well, if that's not enough Zs, we pass that back into the loop. So there's that 42 letters, and we've gone from 17 to 42. That's a huge jump, right? Now we're going from 42 to 110. And again, touching every single letter, right? We have to iterate through every single letter to figure out if we update it to FizzBuzz or FizzBuzz, right? And then, of course, for the really big one, if we jump over here and it's like, oh yeah, we're looking for 1 million Zs. Okay, well, that's 14 loops. And that 14th loop, or that last iteration, takes us from just shy of 2 million characters that we have to iterate through and generate a just over 5 million character string. And that's why this gets slow fast, right? Like it's never going to be a fast thing, no matter if you do recursion or if you do a loop. Neither one of these is going to be fast. Is there a formula out there that could solve this for us? Maybe. But the problem is that we have to generate that string. And because we have to generate that string, we have to generate a new string through each loop. So I haven't been able to find one to make this faster. If you did, please let me know. I would love to see that, okay? But for today, this is the solution. And again, it's not fast. It is painfully slow, okay? But we solved this by bringing in some old code, and we updated it a little bit so that we can send in any element we want. If we don't send in an element, then that element will just be the number, the way that this FizzBuzz L function has always worked in every one of those other videos that I've done, okay? We use that down here. So we created a regular expression to save ourselves some time. Originally, I had this a little bit fancier, but making it so that we can pass in any string, and we're just going to grab all the letters. And then we are going to iterate on those and replace them with something inside of here, right? So here I used a replace and did the math, right? We had to offset by 1 because the offset is 0 indexed and our string is 1 indexed. So keep that in mind, okay? We had to do that. And then, of course, we did it as a recursive function just to see the difference. And the reality is the difference is nothing, okay? Because, again, they're both painfully slow. Every time we go through a loop, whether it's through the recursion or through the while loop, our string gets exponentially bigger each and every time, which makes this slow, right? The more iterations we have to go through, the more characters we have to go through. It's just, that's how this works. So hopefully you found a better way. Please let me know in the comments. I would love to see that. If you like this or you hate this, let me know if you like the recursive one versus the loop one. Otherwise, yeah, this has been FizzBuzz Explosion, and I will see you tomorrow.